Okay. All right, so for the first problem, complete the ionic equation. Initially, I put the 2K3 plus, but then I changed it to the 6K positive plus 2PO4, 3 negative, and then 3Fe plus 3Br negative, and then 6K plus 6Br negative plus Fe3PO4 and then 2. Using the solubility table, I circled Na3PO4, KOH, and CuNO3. So on number 3, I started writing the problem to the video tutorial, but off to the side I wrote the mole-to-mole conversion, or the ratio 2 to 2. So I use CH3OH and CO2. So converting 3.56 moles to the number of moles of O2 required, I found the ratio, which was 3 moles of O2 over 2 CH3OH. So moles of O2 equals 3.56 moles of CH3OH times 3 moles of O2 over 2 moles of CH3OH. That gave us 5.34 moles of O2. And then on number 5, the ratio was 5 moles of H2O over 3 moles of O2. So the moles of H2O was 15 moles of O2 times 4 moles of H2O over 3 moles of O2, which equaled 20 moles of H2O. On the limiting reactants, so let's see. To calculate the theoretical yield and percent yield, to find the theoretical, you need to find the limiting. So 15 grams of C6H12 times the conversion factors, I ended up getting 71.29. And then the other one, my first try, I got 48.09, but I just used the wrong molecules, so I went back and redid that and ended up with the 59.4 of the C6H6Br4. So finding the limiting reactant is always smaller. So the theoretical yield would be 59.4. To find the percent yield, you take the actual over the theoretical, which equaled 55.5 over 59.4. Then you multiply that times 100, and I got 93.4. So the solution stoichiometry, on the left side is the practice problem we did in the meeting, and then so on the right side I use the M1 V1 over N1 equals M2 V2 over N2. So I got the 2.95 times 50 milliliters over 2, and then 49.1 times M2 over 1. So on the left side it equaled 73.75 times 49.1 milliliters of the BaOH2 times M2, and then multiplying that out, you get 1.5 moles